Hello friends, my name is Ankit Tiwari. From now onwards, I'm going to post my videos on YouTube related to important topics of class 9th and 10th, physics, chemistry and maths. My first video will be on the topic derivation of three equations of motion, that is an important topic of class 9th motion chapter. Before deriving the three equations of motion, I will let you know what are the three equations of motion. The first one is the relation between velocity and time. This relation is stated by the equation v is equal to u plus at. The second one is relation between position and time. And this relation is stated by the equation s equal to ut plus half at square. And the third one is relation between position and velocity, that is v square equal to u square plus 2as. So friends, the topic on which I will post my first video will be related to these three equations of motion, and I will derive all these three equations of motion. The first one is relation between velocity and time. The second one is relation between position and time. And the third one is relation between position and velocity. After letting you know what are the three equations of motion, let's start with the derivation of each of the three equations of motion. First of all, I will derive the first equation of motion, that was the relation between velocity and time, that is v is equal to u plus at. But before deriving the equation, I will let you know the conditions of a body related to which all these three equations will be derived. So the condition is, suppose an object is moving in a straight line with uniform acceleration. So all the three equations of motion will be derived on the basis of this condition, that an object is moving in a straight line with uniform acceleration. For that, we have to draw a velocity time graph of that object. So, this is the velocity time graph where x-axis represents the time taken and y-axis represents the velocity. As I have told you earlier that the object is moving in a straight line with uniform acceleration. So let the initial point of the object be A, and it is moving in a straight line, and the final point of the object is B. Let the point where the two axes meet be O. Now, to complete the diagram, I will drop a perpendicular from point B to the x-axis. So this is the perpendicular, and the perpendicular intersects the x-axis at point D. After that, I will drop a perpendicular from point A on line BD which will intersect BD at point C. So this is the perpendicular from point A on line BD intersecting it at point C. Now, after drawing the diagram, I have to let you know all the notations related to this diagram. First of all, first one is U, which denotes the initial velocity of an object. Initial velocity of an object. In this diagram, U will be denoted by OA or CD. So OA and CD will be denoted by U, which is the initial velocity of the object. Second factor is V, which is the final velocity of object. And in this diagram, it is denoted by the line BD. So BD in the diagram denotes V. Third one is T, which is time taken, and T is denoted by OD and AC in the diagram. This is T and this is T. Next one is A, which is acceleration of the object. Acceleration of object. At which rate the object is accelerating is the factor A. Next one is S, which is the displacement of object. And the last one is V minus U. Final velocity minus initial velocity. This can be termed as change in velocity. Change in velocity. In this diagram, what is V minus U? As you can see, BD is equal to BC plus CD. From the given notations, we will insert the respective values of BD and CD. BD is V and I don't know what is BC, and CD is U. After shifting U to left hand side, it became V minus U is equal to BC. So in this diagram, BC denotes change in velocity. So these are the different notations which will be used in the derivation of all three equations of motion which I have taken as the topic. Now, after explaining the diagram and referring all the notations, we will start with the derivation of first equation of motion. While deriving the first equation of motion, the first thing we should know that in a velocity time graph, slope of the graph represents acceleration. So in VT, that is velocity time graph, slope of graph represents acceleration. As you can see in this diagram, the slope is indicated by the line AB. Slope is indicated by the line AB. Now, how do we calculate a slope from a graph? To calculate the slope from a graph, there is a mathematical formula, that is slope is equal to perpendicular upon base. Perpendicular upon base. Now, referring to the diagram, we will insert the values of slope, perpendicular and base. I have told you earlier, slope is indicated by AB, perpendicular is BC, and base is AC. All three factors are taken from the triangle ABC. So they basically belong to triangle ABC. Now, referring to the notations, we will insert the values of AB, BC and AC. AB is A, that is acceleration, because slope of a velocity time graph represents acceleration. BC is V minus U. AC is T. Now, I will shift T from right hand side to left hand side. A into T is equal to V minus U, and by shifting initial velocity, that is U, from right hand side to left hand side, I got V is equal to U plus 8. Now the first equation of motion is derived in this way. After deriving the first equation of motion, we will switch on to the derivation of second equation of motion. In the derivation of second equation of motion, we should know that in a velocity time graph, area under the graph represents displacement of the object. So, as the area under the graph will be the area OABD. So, in velocity time graph, area under the graph represents displacement of object. Thus displacement will be equal to area of OABD. That is area of OABD, this area. As you can see in this diagram, OABD includes a triangle ABC and a rectangle OACD. So, displacement will be equal to area of triangle ABC plus area of rectangle OACD. From the notations, displacement is denoted by the symbol S. So below displacement, I will note down S is equal to area of triangle ABC. As it is a right angle triangle, so the area of right angle triangle is half into base into height, and the area of rectangle is length into breadth. So half into base into height plus length into breadth. From the figure, I will insert the values of base, height, length and breadth. In triangle, base is AC and height is BC. Base is AC and height is BC. In rectangle, length is OD and breadth is OA. Length is OD and breadth is OA. From the notations, I will insert the values of AC, BC, OD and OA. AC is T, BC is V minus U, OD is T, and OA is U. So we can write UT plus half into T into V minus U. In the second equation of motion, the second equation of motion was S is equal to ut plus half at square. As you can see, there are total 4 factors. First one is S, displacement. Second one is U, initial velocity. Third one is T, time taken. And the fourth one is A, acceleration. In this equation, V is not available. Okay, so while deriving this equation, we will try to eliminate V from this line. Now, how we can eliminate V? We can eliminate V by inserting the value of V from the first equation of motion. So, insert value of V is equal to U plus AT from first equation of motion. As in the second equation of motion, there is no requirement of V. So this will become S is equal to ut plus half into T into U plus AT minus U. In place of V, I have inserted U plus AT from the first equation of motion. Plus U and minus U gets cancelled. So this is S equal to ut plus half into T into AT, which is finally S is equal to ut plus half AT square. Thus, the derivation of second equation of motion is completed, and in this way we can derive the second equation of motion. The first two equations of motion, I will switch on to the derivation of third equation of motion, which was the relation between position and velocity, and stated by the equation v square equal to u square plus 2s. In deriving the third equation of motion, we will consider the same condition that in a velocity time graph, the area under the graph represents displacement. In velocity time graph, area under the graph represents displacement. So displacement will be equal to area of OABD, because area under the graph is area of OABD. But there will be a slight change in the diagram. And why that change will occur? First, I will make you understand why that change will occur. As you know, the third equation of motion was v square equal to u square plus 2as. In this equation, we have got 4 factors. The first one is final velocity, second one is initial velocity, third one is acceleration, and the fourth one is displacement. As you can see, time factor is not included in this equation. So, the slight change in the diagram is that I will omit the line AC, which I have earlier dropped a perpendicular from A on line BD. So I will omit this line AC because it represented time taken. Now, as I have omitted the line AC, if you look into this figure, then this figure consists of 4 sides, 1, 2, 3 and 4, that is OA, AB, BD and OD. So it is clearly stated that it is a quadrilateral because a quadrilateral has 4 sides. But it is which type of quadrilateral? As OA is parallel to BD, then a quadrilateral with a pair of opposite sides parallel is called a trapezium. Thus, OABD is a trapezium. So I will omit this equation. OABD is a trapezium because it is a quadrilateral with a pair of opposite sides parallel. Thus, displacement will be equal to area of trapezium OABD. Now, what is the area of a trapezium? The area of a trapezium is half into sum of parallel sides into height. So, in place of displacement from the notation, I will write S and I will write the formula of area of trapezium. Half into sum of parallel sides into height. From figure, I will insert the values of parallel sides and height. Now S will be equal to half into OA, one parallel side, and BD, another parallel side. OA plus BD, and the height is, as you can see, this is an inclination, so it cannot be a height. Height is OD. Now, by inserting the values from the notations of OA, BD and OD, we get S equal to half into OA is U, BD is V and OD is T. So we can write it as half into V plus U into T. As I have told you earlier, in the third equation of motion, time factor is not included. So we will insert the value of time t from the first equation of motion. So insert value of t from first equation of motion, which was v is equal to u plus at. So v minus u upon a is equal to t. So I will insert the value of t equal to v minus u upon a in this equation. Now S will be equal to half into v plus u into v minus u upon a. So S will be equal to v square minus u square upon 2a. Lastly, I will shift 2a from the denominator to the left hand side. So it will become 2as is equal to v square minus u square, which is the third equation of motion. But I want to state you one more thing, that why I wrote v square minus u square, how it came. As you can see, this is v plus u and this is v minus u. In maths, there is an identity that is a plus b into a minus b is equal to a square minus b square. So from that identity, I got v square minus u square. Now friends, I have derived all the three equations of motion, which was v is equal to u plus at. Second one was s equal to ut plus half at square. And the third one was v square minus u square is equal to 2as. So friends, I hope you like my first video on YouTube. See you soon with some interesting topic related to class 9th and 10th. Thank you.